Hey space friend, I'm getting a little paranoid about something lately. Imagine if some advanced alien life were to stumble upon us like this someday. Hey, take the space binoculars and look at this idiot who broke her ship. Whoa, that is embarrassing for her. I bet she doesn't even know how to reverse the polarity of the neutron flow. It's so nice being a superior life form. Yeah. Embarrassing. Also not the accent I would have expected aliens to have. But don't panic, because I have a plan for that. In order to impress these hypothetical aliens, I'm wearing an outfit that Party City believes to be an alien costume, and we're gonna do some magic. And by that I mean use the Arduino Magic Light Cut module. A module in the Arduino environment is a ready-to-use board that has a sensor or an I/O device on it. Using these limits the amount of additional components that you need. Instead, the module integrates the necessary components and connections that are required for the sensor or I/O device so that you have an easy, ready-to-use product. The Magic Light Cut module incorporates an independently controlled LED and a glass mercury tilt switch. The name of this module is due to it looking like you're pouring light from one to the other whenever you tilt it. The tilt switch includes a small amount of conductive liquid mercury. A mercury switch is an electrical switch with a tiny ball of liquid mercury inside a glass casing. The electrical circuit opens and closes as the ball of mercury rolls around and either makes or breaks contact with electrodes. When tilted in one direction, the mercury touches a set of contacts and completes an electric circuit. When tilted the other direction, the mercury rolls away and breaks the circuit. With the Magic Light Cut module, the output of this tilt switch is a digital signal that then triggers pulse width modulation to dim or brighten the LEDs on each module. This is a pretty simple project to set up. We're only going to need 2 Magic Light Cut modules, 8 male to female jumper wires, and 1 regular jumper wire. This time, instead of connecting everything through the breadboard, we're going to connect the module directly to the Arduino. So pick a module to be A and one to be B, doesn't matter which one. The L pin is for LED and the S is for switch. So on module A, connect the L pin to 6 on the Arduino and the S pin to 7. Connect VCC to the positive sign on the power rail and ground to ground on the Arduino. For module B, connect the L pin to 5, the S pin to 4, VCC to the power rail, and ground to ground. Then connect a jumper wire from the power rail over to 5V. We're first going to set some variables for the LED pin, the switch pin, our tilt state, and then the brightness. The brightness is going to be affected using pulse width modulation, so it can be a number anywhere between 0 and 255, and we're going to start it out at 0. Under void setup, we're just setting our pin modes. We're taking LED is our output, that's what we're writing to, and the switch pin is the input where we're getting the information from to know what to do with the LED. Under void loop, we have 2 if statements. We don't have an if else this time, so both of these things can be true. If the first if is true, it's not going to automatically skip down to analog right at the bottom. It's going to execute both of these if statements no matter what before it gets to analog right. So in the first part, it's reading in the tilt state of module A. Then it's checking if that tilt state is high or on and the brightness is not 255. Then we're going to increase the brightness until it gets up to 255. Then the next if statement is going to execute, reading in the tilt state of module B. If it's high or on and the brightness is not 0, then we're going to decrease the brightness until it gets down to 0. Then we go down to our 2 analog write functions. We're going to write whatever the brightness variable is at this point to LED pin A, and then to LED pin B, we're going to write 255 minus the brightness variable. Then we're going to delay it by 25 milliseconds. So this can be a little confusing just to look at, so let's walk through the first few iterations of the loop just to understand exactly what it's doing. So loop number 1, we've got A tilted and B not tilted. So if tilt state A is high and the brightness is not 255, increase the brightness. A is tilted, the brightness is at 0 at this point, so we're going to increase that to 255, which is its max brightness. Then we're reading the tilt state of B. B is not tilted, so we're going to skip that if statement. So at this point, the brightness variable is now at 255. So we're writing to LED pin A the brightness of 255. So that turns all the way up to its max brightness. And then to LED pin B, we're writing 255 minus brightness. So that goes down to 0. Loop number 2, we've now tilted module A back to not tilted, and we've tilted module B. So if A is high, it's not, so skip it, go to the second if statement. If B is high, yes, and the brightness is not 0, yes, because it's at 255, decrease the brightness until it gets all the way down to 0. So analog write to LED pin A, the brightness of 0, that one turns off. Write to B, 255, minus the brightness of 0, so that one goes all the way on. Whew, getting that module figured out is a huge weight off. Now, if any aliens find us, instead of greeting us like this, they'll greet us like this.